Welcome to Spring Lib.
Hydrogen atom is in p state, so we have L equal to 1. The value of magnetic quantum number goes from minus L to plus L, including 0. So for L equal to 1, we have three values of magnetic quantum number. These are minus 1, 0, and plus 1. Z component of orbital angular momentum is equal to magnetic quantum number times h bar. So we have three values of z component. The first one is minus h bar, the second one is 0, and the third one is h bar. Also, we have the z component of spin angular momentum is equal to spin quantum number times h bar. Here we have only two values of spin quantum number. These are plus half and minus half. So we have the first value of g component of spin angular momentum, that is equal to half of h cut, and the second value is minus half of h cut. We can write the z component of total angular momentum as sum of z component of orbital angular momentum plus z component of spin angular momentum. Now we want to draw a table showing all the values of z component of orbital angular momentum and z component of spin angular momentum. Here we have Lg, here we have Sg, here we have z component of total angular momentum. Here we have Mj, that is the quantum number related to total angular momentum. For Lg equal to h bar and Sg, that is half of h cut, we have Jg, that is sum of Lg and Sg, that is equal to 3 upon 2 h cut. As Jg, that is also equal to Mj into h bar. So this gives us mj equal to 3 upon 2. Now for the second case, we have Lg equal to h cut, Sg equal to minus half of h cut. This gives us g component of total angular momentum equal to half of h cut. So we have mj equal to half. Now for Lg equal to 0, and Sg equal to half of h cut, we have Jg equal to half of h cut and mj equal to magnetic quantum number equal to half. And for Lg equal to 0, Sg equal to minus half of h cut, we have g component of total angular momentum equal to minus half of h cut, and we have quantum number equal to minus half. Now for g component of angular momentum equal to minus h cut, and for g component of spin angular momentum equal to plus half of h cut, we get g component of total angular momentum equal to minus half of h cut. This gives us spin. This gives us quantum number related to total angular momentum equal to minus half. Now for the last case, for g component of orbital angular momentum, that is minus h cut, for g component of spin angular momentum, that is minus half h cut. This gives us g component of total angular momentum equal to minus 3 divided by 2 h cut. This gives us quantum number equal to minus 3 upon 2. So for j equal to half, we have two values of the quantum number. These are plus half and minus half. For j equal to 3 upon 2, we have mj equal to plus minus half and plus minus 3 upon 2. Here j is the quantum number. We can write magnitude of total angular momentum equal to square root of j into j plus 1 multiplied by h cut. So for j equal to half, we have the values of z component of total angular momentum, that is half of h cut and minus half of h cut. So similarly for j equal to 3 upon 2, we have the z component of total angular momentum equal to 3 upon 2 h cut, half of h cut minus 3 by 2 h cut and minus half of h cut.